Okay, welcome everybody. This is going to be a in-depth lab. It should take you about a class and a half. So please ensure you have everything you need. This being the lab, this is the actual physical lab you're going to need. And this link that you're going to notice right here is absolutely vital. You will see that it's available off of the D2L announcement page. But please make sure you can actually access that and you have either a physical copy of this in front of you or you have the digital copy open up on your desk. Okay, so pause this video if you don't have this yet. So I've attempted to embed a video in a video to try and help you out, but I'm just going to give you a quick run through just in case the video does not work. So one of the things, please make sure that you have created the proper setup for your lab. So you again need to make a series circuit. Again, please use the tools down at the bottom. You need the pencil to actually highlight the different things that you want to place. And so when you start looking, this is going to be a resistor, so I just need to highlight that in order to grab it. These small boxes are going to be your ammeters. And please make sure that you have 9 volts sitting at your battery. Okay, and please make sure that all of your resistors are only 10 ohms. That's going to be really, really important. All right, welcome everybody. I'm going to hopefully give you a quick tutorial on how to use your circuit builder. So please make sure that you've actually got to this page, and all you need to do is hit the launch button in order to see this. And so I'm just going to make this slightly larger so you can see. So I need to first build my circuit. So if you look down here at the bottom, I have a pencil. And then whatever is highlighted here on the bottom are the objects I can place in there. So I have my wire highlighted, so I can just go in and I can just place in wires. If I look at your sheet that you have for your lab, so again, it looks a lot like this. All right, so please, again, make sure you have this because this is the lab that I am going to be following through. It's also available on D2L. So pause this video if you don't have that and make sure you understand what it is I need to do. So if I look at the lab, I'm supposed to have 3 resistors, and then after every resistor I have an ammeter. So again, every time I want to pick up these objects, I'm just going to go on the pencil and I'm just placing the objects in. Okay, so if I need another resistor, it's now highlighted. I now can just click. And then if I need an ammeter, this is the little thing that has a 0A. Again, I can just lay this in. So if I look at the instructions, this is hopefully how my series circuit should look. And then of course I need to finish the connection. So I should see now flowing electrons. So a few things I want to point out that are going to be really, really important for you to see. Number one, I can actually take a look at what the values of each things are because there are presets. So if I click, instead of on the pencil, I go one down and I'm on the battery symbol right here. I now have a little magnifying glass that I can now move over every object, and whatever it's over, it will read or it'll tell it to me. So I'm going to check that, yes, I have a 9-volt battery. I can change that voltage by just hitting up or down. The instructions say 9. I'm going to click over my resistor, and it says 10 ohms. This is good because all 3 of these should be 10 ohms, so that's correct. So now when I take a look, I actually should now see a flowing circuit. So in your lab, this is now what you need to explore. You should be able to fill in the values. When it's asking for what is the reading of the ammeter, I don't need to do anything else. I can simply see it right here. It says 0.3 amps. If you want to, you could go into the third little tag here, and I can actually put in physical meters. So one of the things, I wouldn't worry about your amp meter. Don't worry about the purple one because we already have them embedded as we go. But one of the things I can see is I can see the voltage. So all I need to do is I can just take these and I can rig these up, and then I should see running across, it's going to give me a value. So this voltmeter is reading 3. So that tells me across this junction here, across this resistor, I need 3 volts of push to get it across. The other way I can see it is if you notice there is a white circle, you would on your lab write in 9 in that white circle and 6 in this white circle. You can also check here at the second resistor. Again, 6 volts went in because that's what I had at the end of the first resistor. And again, if I take a look, 6 went in and 3 went out. I can either do some basic math and just subtract the 2 because 6 minus 3 is in fact 3, or I can hook up my voltmeter, and again, this is in parallel. It's running across the load or across the resistor. Again, it's giving me 3, and I can do the last one And this is what I'm going to set it up this way. You're going to notice that I have a negative voltage, and that's because these leads are reversed. What it's telling you is that it needs the red and the black to be just in this order. A negative voltage is fine. It just means it's going in the other direction. Okay, so you'll notice that at every single resistor, I used 3 volts of push. And this is the really important summary that I need you to make sure you can see, is that if I look at my total voltage, I have 9 volts going out. I used 3 at the first resistor, I used 3 at this resistor, and I used 3 at the third resistor. So 3 plus 3 plus 3 is in fact equal to 9, and that's exactly what my battery is giving me. So in order to look at the voltage in a series circuit, the voltage is going to be different at every resistor, but it must total the total voltage at the battery, okay? The one thing that is consistent is I have 0.3 amps of power. So I hope that helps, and then I'm going to reset it when we have to alter our next lab. So if you're on this slide, that means you have completed the first task, and now you need to actually fill in your data points. So please make sure you understand how to actually fill in your table. So if I've done everything correctly and I've had the lab looking exactly what you see here, the current is going to be the same across everything. So I can put in 0.3 amps in every single section on my table. So your current will always be the same on a series circuit. This is going to be a really key highlighting point, okay? The potential difference for my voltage. This is where things get a little bit different. So remember that at resistor number 1, I went in with 9 volts, but I came out at 6. So I ended up getting 3 volts there. For number 2, I ended up I had 6 going in, but 3 coming out, which means again, I used 3. And then at the third one, I had 3 going in and 0 coming out, so I had 3. So this is actually the answer. You're looking at 3 volts per. Now I want to be really, really careful is that when you take a look at your voltage on a series circuit, they all seem to say 3 right now, but that's only because I had the same resistance. So your voltage basically in a series circuit is how it works is whatever the voltage is at the battery. This is how I would say it, just V at the B. It is going to be the sum of the voltage at resistor 1 plus the voltage at resistor 2 plus the voltage at resistor 3. So for us, we had 9 volts at the battery. The first one used 3 volts, it used 3 volts at the second, and the same at the third. And so this makes sense. But please note that these are the same only because the ohms are the same. We're going to take a look at this really important detail at the next slide. Okay, so for task number 2, you need to reset your lab. So again, please make sure you can pause this video and ensure that your screen, your circuit builder looks a lot like this. So the one key thing I want you to make sure you understand is that please have 14 volts at the battery. So I need to change my battery to 14 volts. You can even put that into your table. You then need to make sure that you have 3 different resistors. So 3, if I want 5, 10, and 15. So this is going to be a 5 ohm resistor. This one here should be 10 ohms, and then the one on the bottom should be 15 ohms. So please pause and make sure you do that. Okay, welcome back. If you're watching the second video, one of the things I want you to make sure you do is I've altered task 2, and it will actually work better for you. So please make sure you're changing the voltage to your battery to 14. I just asked you to change the voltage originally. Please change it to 14, and then make sure each resistor you have a 5, 10, and a 15 ohm resistor. And you can actually consider your beginning table to look a lot like this. So if I go back over to the lab, and again, I make this a bit larger, again, I've reset everything. So you're gonna notice there's a difference. So again, I can double check on my second little icon here, my battery icon. I in fact have a 14 volt battery. My first resistor is 5, my second resistor is 10, and my third resistor is 15. So now what you need to do is, again, the same idea. I want you to take a look at the relationships here. So one of the things you have to do is, what is the total current in this system? I can read that really easily because it's 0.5 amps. Now, another thing you can do is you could actually calculate this by taking what is the total voltage and what is the total resistance. And I could actually, using Ohm's law, I could predict this. I could calculate it, and it will come out as 0.5. Now, what you're going to notice, the voltage is a little different, because remember, these all have different ohms or different resistant qualities. So if I take a look here at my first resistor, I have 14 volts going in, but I only have 11.7 going out. So I can do a little bit of math, or I can see how much push was needed to essentially get those electrons passed. So I can set up my voltmeter. Again, I need to measure it across, and you're gonna notice I use 2.33 volts. Now this makes sense because this is a 5 ohm resistor. I don't need a whole lot of push because it's only 5 ohms. I can also just take in my head 14 minus 11.7, and I'm gonna get 2.3. Now, if I quickly compare to my second resistor, this is going to need a little bit more push. You're going to notice that it's now 4.67. Now, again, this is just for rounding, okay? This, again, makes sense that I would need a bigger push to get across this resistor because this is a 10 ohm resistor. And then if I go to my last resistor, which is 15, I want you to kind of predict, are you going to need more or less than my 4 ohms or my 4 volts to get across my last one? And hopefully you've predicted that yes, it's going to be more because this is, again, a 15 ohm resistor. Okay, so that's 15 ohms. So it makes sense that I need a bigger push to get across. But if I add up what is the total voltage across each individual load, it is going to be whatever the voltage is to make sure I can actually reach a 0.5 of an amp. How much of a push do I need to get it across? Because I can't go faster or slower than 0.5 of an amp, because that is set. That's what a series circuit is. But I can't exceed 14 volts. If with all of my resistors, I really need 20 volts of push, but my battery is only supplying 14, this circuit simply will not work because I don't have enough potential energy to make it across every single junction. All right, welcome everybody. Please make sure that for this next section, you've paused this video and please build your parallel circuit according to what you see. So a few things I'd like to point out. Please make sure your battery is a 10-volt battery. So please just, again, go to your little pencil here, build it in, and then you can change your voltage by actually tagging on that second one and increase it to 10 volts. And you also need to make sure that you have 3 10 ohm resistors. So please make sure that that is set. And then I want you to make sure you put in your ammeters in the right spot. So there should be an ammeter after every resistor, and there should be one more at the battery right here. So these sort of purple blocks you see should be your 3 ammeters. Now, one of the things that you should see, and please pause the video until that you are done this, is I should be able to see certain numbers. So the total voltage that's coming out of my battery is 10 volts, which means 10 volts are going to go into every circuit or every single path. But you're going to notice down at the bottom, it reads 0 every single time. And that's because 10 volts was delivered at every single path. So that's great. The one thing about a parallel circuit is it supplies the same amount of push for every single circuit, which is great, but that also means that your battery is going to drain a lot quicker. Now, the other number I want you to really watch are your total amps. So in at the battery, you should see 3 amps going in. And if I look at every path, I should see that there's only 1 amp per path. And I'm hoping this makes a lot of sense to you, because if you go back and you look at how parallel circuits work with current, your total current, I can calculate it or I can just figure it out. So pause this video to make sure you can actually figure out how would you actually calculate your total current if you knew your total resistance. And remember, resistance for a parallel circuit is a little trickier. So again, hopefully you've been able to figure out that your total current is going to be 3, because my total voltage was 3 and my total resistance was 3.3. So remember, if you were struggling to figure out how do you figure out your total resistance, all I did is I took the sum of all of the 10 ohm resistors, but remember I have to use my inverse, and then I need to make sure that I hit the inverse again, and I should get 3.3 repeating. So this is an important step. If you don't know how to do that, please pause and make sure you can get the same number. So the other thing that I want to point out again is your voltage. Your voltage is going to be equal all the way through. So when you look at your voltage for a parallel circuit, how we would write it is that the total voltage at the battery is going to be equal at spot 1 or at path 1 is going to be equal to path 2, and it's going to be equal to path 3. So what I'd suggest you do is you pause this and see if you can see those comparisons between a series and a parallel circuit. So when you look at this page, I've already sort of helped to fill this in. Again, please make sure you can understand the essential summary. So in a parallel circuit, the one thing that is the same for every single path is your voltage. It's shared equally across every single circuit. Whereas your current, however, it's going to be the sum. So again, if I have a higher resistor at each of these individual paths, I'm still going to get 10 units of push going in. I cannot change that, but the speed might change. And that's what you're going to explore in the next section. Okay, so on your last task here, there's a few changes you need to make sure you do. Please ensure that you have a 9-volt battery. So again, one of the things you can already predict that going into each path, you're going to have 9 volts going in. That's going to be set because this is a parallel circuit. The one thing you do need to change is your resistance. I want you to make sure, and I know in your lab I've given you 5, 10, and 15, but you're going to notice it's not going to work. So please change 5, 10, and 15 to a 10, 15, and 20 ohm resistor. If not, I'm literally going to blow my circuit because I don't have enough resistance and the current's going to be moving too fast. So if you set everything up correctly and pause this video to make sure you do, what you should see is your final current going back into the battery at 1.9 amps. That should be your total current. And if you go through at every single resistor, you should see, and this is going to be a really important learning point, on my first path, which only has a 10 ohm resistor, it's going to be going the fastest at 0.9 amps. Because again, it's getting 9 units of push. Over the 15 ohm resistance path, it's going to slow down a little bit because again, I have a higher resistor. I only can push with 9 units of push because that's all the battery will supply. So my speed or my current is 0.6. And then over my 20 ohm, you should have the lowest at 0.4. So if you add these all together, and again, this is an important part to how to calculate the total current, is that if my battery total was 1.9 amps, my sum of all of the other ones have to equal this. So I should have 0.9 plus 0.6 plus 0.4 is going to give me my 0.9. When I look at my voltage drop, again, the voltage at the battery is going to be the same. This is a key thing on parallel circuits, is it all going to be equal? And again, your total resistance, this is one that a lot of you are going to struggle with, but we're going to keep persevering. Again, all I'm going to do is I take the inverse of 10 plus the inverse of 15 plus the inverse of 20 on my calculator. And if you do that, you're going to find that your total resistance for this whole system, okay, is going to be 4.61 ohms. And I can even double check this calculation. And what you should see, if you actually just wanted to calculate your total resistance, if I were to take my total voltage, which I know is 9, and I divide it by the total current, which I know is 1.9, you should be getting an answer very, very close to 4.7. Now, this is going to be slightly different than the 4.6 we figured out here, and that's simply due to rounding. But you should see, again, I can either calculate it, or again, I can do it basic math by looking at each individual pathway. So I hope that helps. So one of the most important things that you need to make sure you do that for the rest of the lab, so if you look at task 6, this is what's for marks. So task 6, you're going to basically put it all together. So there are a few questions that are going to be on D2L. So when you are ready, you can use this just as your working copy, but you're going to head over to D2L and you're going to be entering your answers for all of task 6. The one thing I did take off was drawing a schematic diagram because it's just not D2L friendly. So good luck, and if you have any questions, let me know.